So, here to talk about cloud performance, particularly as regards to desktop as a service. And a lot of the stuff that I'm going to talk about today was just kind of in my mind, and I hadn't done any of the testing, and I hadn't written anything down yet. And when Mark asked me to come and present on some kind of VDI performance related issue, I was like, well, this is my chance. I can now do the work and write the things down that I've been worrying about or thinking about over the last few months. So it was a great excuse to actually do some work. So my name is Jim Moyle. I do work for Microsoft. I'm Senior Tech Evangelist for Windows Virtual Desktop. I'm also a CTP and have been for 9 years or something like that. And, you know, one day when you grow up, Case, you'll... you can find me on Twitter at Jim Moyle, and I also have a YouTube channel where I post videos about this kind of thing, and YouTube/Jim Moyle. Having said all this, I do not have my Microsoft hat on today. Okay? This is a community session, and there's a lot of maths in it. I hope you like graphs, because we're going to see a lot of graphs. All right? I might even break Excel out at some point, if you're lucky. So I have to say this. None of what I'm going to talk about today is from Microsoft. This is just my personal opinion. I don't want anybody going on Twitter and saying, Microsoft this, said this, Microsoft that. I don't want to see that. So bear in mind, this is just me, it's just my personal opinion. Everybody clear? All right, good. Hopefully now I won't get in trouble. So as I said, we're talking about desktop as a service. And not hybrid, we're talking about cloud-only desktop as a service. And if we look at the VDI Like a Pro stuff, let's ignore the blue bar, that's not the one I want to talk about, it's the third one down. Most important Workspace initiatives for the coming year, the third most important is desktop as a service. So I think it's going to be fairly relevant to a lot of the people here who either are testing it or proof of concept, or maybe you've even got some production workloads running in the cloud already. Actually, let's ask, who's got a production workload running on desktop as a service right now? One person. Brilliant. Who's had a look at it, who's had a play with it and run some VMs up and stuff? Many more people. Okay, good. So I just talked briefly about Windows Virtual Desktop. I've only got 2 slides on this, and then we'll stop talking about it. It's the only way to get Windows 10 multi-session is running in Azure. You can run it with VMware, you can run it with Citrix, you can run it with Workspace, and I think there's a couple other people as well. There's some really good stuff for Office 365 Pro Plus, not just the acquisition of FS Logics. There's core changes gone into Windows 10 and core changes gone into the Office suite as well to make it much happier in a virtualized environment. You can bring your existing workloads and push them straight into Azure if you want. And this last one, deploy and scale in minutes. It wouldn't be a slide about the cloud if it didn't say something like deploy and scale in minutes, right? We're going to take a really good look at that now, today, and see how true that is and how that actually works, okay? If you did want to try this out, then WVD is globally available. Any Azure data center you can run Windows Virtual Desktop in, and the control planes are in these locations, as we can see. All right, so that's the WVD stuff over with. Everything I'm going to talk about now, although I do work for Microsoft, so I'm going to use Azure terms, right? But this is not just relevant to Azure, this is relevant to every single other cloud that you want to run these kind of workloads in, right? It's maybe slightly different terms, it may be slightly different limitations, but the stuff I'm telling you about will translate to every cloud, not just Azure. Yep. So that's scaling. Now, when I first started looking at scaling out to large numbers of users on desktop as a service, turns out there may be a couple of small issues in terms of, or stuff that you need to keep an eye on. Let's have a quick look at what Citrix say about this, yeah? And this is kind of the same thing that we know from on-prem. You keep a buffer of VMs ready for people to log on, and then as people log on, then you spin up more VMs, and as they log off, then you shut them down, and then you keep your buffer at the end, right? Everybody knows this. Now, Citrix also allow you to have different settings for weekdays, peak and off-peak time, and there is interesting subtleties to each of the vendors, each of the control planes as to how they do scaling. I'm not going to tie this to any specific vendor or any specific control plane, so I'm making the scaling as simple as possible. So we're just going to do buffer, and then you get more VMs as you go along. How much capacity do you need to stand up? It's all about concurrency, right? So you work out what concurrency you need, which is max historical concurrency, yeah? So what was your max number of people? And then you'll guess, you'll take a bet on what that safety buffer should be on top of your historical max, just in case. Yeah? Now the trouble with this approach is that maybe your day-to-day concurrency is 600 users. Your max historical is 1,000, 10% buffer, and you may be thinking, well, I need to stand up enough resource for 1,100 users, but I'm only getting 600 every day. So is that 500 users worth of wasted capacity? Well, maybe, depends on how you do it. But nobody likes paying for VMs when nobody is logged into them. Nobody minds paying for VMs where there's loads of sessions and people are working, but where there's nobody logged into them. People hate paying for that, and you can't blame them. If you're curious, there's actually three different statistical models which will predict what are called rare events, which we can use to predict, without guessing, your safety buffer size. I'm not going to talk about these today, but I wanted to mention it to tell you it's there. So if you like maths and statistics, you can go and look that stuff up. So this is real data from, this is actually on-prem data. 5,000 users over 1 week, Monday, Tuesday, Wednesday, Thursday, Friday. They're a slightly odd company in that they allow their users to have disconnected sessions for 6 days. Yeah. Which is why you don't see those, the bottom of the peaks coming back down to 0 overnight. There's people leaving disconnected sessions on overnight and coming back tomorrow morning and logging back into their applications. Now, this sort of real data was too hard to work with in terms of showing you this, so I've simplified it. All right, maybe that's a bit too simple. Okay, let's go back to this. We got midnight to midnight. We've got an hour between 8 and 9 p.m. where users come in and log on. Yeah, and we've got that 600 users concurrency that we were talking about before. And magically, they all log out at the same exact moment. We'll deal with that later. So just visually, what's the difference between the capacity for 600 users and the capacity for 1,100 users? That's a large difference in terms of what you're paying for, right? So there's two ways to allocate resources. You can either do reserved instances, or you can do pay-as-you-go. most people I see doing pay-as-you-go. Because they've sat down and they've done the maths. It's like, I need this many for the working day. I don't even need that many because I've got that curve. Yeah? And if I'm paying for reserved instances, I need to do that 1,100. Even though reserved instances are significantly cheaper, you're kind of thinking, well, actually, pay-as-you-go is better. And I see a lot of people doing that. And that whole thing that we used to have with follow the sun and sharing resources, everybody knows this on-prem. So, you've got 600 users in Amsterdam, you've got 600 users in New York, and you've got 600 users in Singapore. Then the easiest way to do this is to stand up one farm and have everybody connect to it so you're not having to buy the same resource around the globe. Doesn't make any sense in cloud because you can stand up and stand down those VMs wherever you like, so you should always create those VMs near to the user. So again, this is kind of against that reserved instances thing, although reserved instances do span a subscription. So you can do reserved instances and stand one up in New York and one up in Sydney if you want to do so. But it does mean that cloud has changed the way we think about stuff in that way. Also, do you deploy everything and then your scaling is just powering up and switching stuff off? Or do you do create, destroy? So WVD right now does deploy and then power on, power off. Citrix MCS does create, destroy. Now, I kind of really like create, destroy because two things. You're not paying for the storage. And every time you boot that VM, you absolutely know it is in the correct configuration directly from your master image. And you know that every single time. So I like create, destroy. We'll get into why that's not as simple a choice as you would think in a little bit. So, deployment time. What I mean by this, for the purposes of this presentation, is how long it takes for you to scale up till that VM is ready for a user to log into it. So either creating it, or creating them booting it, or beating it, then for the agent to register with the control plane, and then for the control plane to say that that VM is now available for users, right? That time is super important. Now, if there was such a thing as instant clones in the cloud, we wouldn't really care about this because we wouldn't have to keep any buffer, we wouldn't have to keep any excess, yeah? We'd only have to spend the exact amount of money that we're taking. So the longer the deployment time, the performance of the underlying cloud infrastructure and the control plane and the agent, that performance then becomes a key metric for how much money you have to spend. Yeah, because at zero deployment time, you spend no extra. And the longer your deployment time is the more money it's going to cost you. Told you there'd be some graphs. The area in blue is the same as we saw before, but this time it's 1,000 users. And this is kind of exactly what we talked about, right? This is when it's working perfectly. So I've got a buffer of 20%. And again, everybody logs off instantaneously. And this looks okay, right? You're still spending 35% of your cash, if this is pay-as-you-go, on VMs that have got nobody logged onto them. It's a significant amount of cash, and that's when it's working perfectly. So what does it look like when it stops working perfectly? So because this type of scaling is reactive, right? You can only start that process off of deploying new VMs or turning on new VMs when your first user logs on and you realize you need more capacity. So if your rate of deployment is slower than your rate of users logging on, yeah, then at that point is the first time you can start scaling. And because this line here is slightly less steep than that line, it means that you now have to keep 42% in your buffer just to cope with having enough VMs on. Because if you miss that corner off, effectively what's happening is you will have no VMs for people to log on to, right? And that is the cardinal sin of our industry, right? That's like a sackable offense if you end up consistently saying, yeah, I didn't get my scaling right and people couldn't log on and couldn't work. So this means that you have to put your buffer higher. So this is what I'm talking about with the consequence of the performance of the underlying deployment time having a huge effect on how much money you need to spend to make this work. If I slightly change this, so now it's about 50-50 in terms of spend. All right? Now, this is the same rate of deployment, this is the same speed of deployment as that first slide that looked perfect, but now scaled up the number of users from 1,000 to 10,000. And now it's really bad with the amount of VMs you have to keep up in your buffer, so you've got enough VMs for people to log on. Are people following what I'm talking about here? Is this, yeah? Okay, good. Somebody will look at me like, what, you what? All right, as long as most of you are following, I'm happy. And now you're paying 57% of your entire spend is for VMs that are not doing anything. And if you start reporting that up to your manager and saying, look, this is going to cost that much. How much are we using? 43%? Doesn't look good. I was going to do an exciting Excel demo. Should I do it? Because I can show this graph for any number of users and any start time you like. Does somebody have an environment they'd like to see if it works or not? Yeah? Does somebody want to volunteer their numbers? No? Okay. Yes, come on. Right. I'll tell you what, because of time, if you want to come up to me and say, what does my environment look like in those graphs, then just come up to me afterwards and we'll have a look at that. VDI like a pro again. So those numbers when I'm talking about 1,000, 5,000, 10,000, those aren't ridiculous numbers, right? Because that's in that big popular range. We do have like hundreds of thousands. You don't usually see more than sort of 30,000 in a single deal. Even if you've got like 120,000 users, I've never seen more than like 30,000 in a single one. But even so, you can see that this scaling and this rate of user intake can get really severe. The larger you are, the more severe this gets. The reason why you may not be able to scale out so quickly is every cloud has rate limits on its API. Every API in the world has a rate limit. Effectively, it's there to stop somebody DDoSing the API and bringing the entire thing down. So if you look at the management there, so this is per principal user ID. Now, a lot of the DAAS solution will use one UPN. Per hour, 12,000 reads, 1,200 writes. So if you get 1,200 REST writes through that API, and deploying a VM is deploy a VM of this size, attach that disk, and boot it, only 3 REST calls, write calls per VM, right? You can only do 400 VMs at that rate, an hour. That's what's stopping us pushing out as much capacity as we would like to. Now, those are the SLAs. Quite often you'll find it's higher, but obviously you have to work to the SLAs, because if you rely on something that's not within the SLA and you go and complain about it, you will get told, tough shit. We never promised that we would do better than that. And if you run out of writes, by the way, it doesn't slow you down. You've run out till your hour then ticks over and you get another 1,200. So what happens is your initial burst will go quickly. So everything works in your proof of concept. It works in your pilot. Everything looks lovely because you've got low numbers. And then when you scale out, you start running into API limits. There's another good one, which is like checking the power state. Because the broker checks the power state of all the VMs, makes sure they're on. There's a limit in terms of how many times you can query a power state in an hour. There's a load of these. Yeah, it's not just deployment, but there's a whole load of these which are not necessarily clearly called out. Now, for Azure, you can at least go and see them. If you do get AZ resource group debug, then you can see the amount of API calls you have left in that time period for that subscription and that resource group. So if you're doing proof of concepts and you're doing pilots, this is a really good number to know. Because once you know this number, then you can predict what your scaling limits will be. So this is a number you need to really keep an eye on as you're testing and doing the initial rollout. I like ephemeral disks. Ephemeral disks don't cost anything. They live on the local storage of the hypervisor. The trouble with ephemeral disks is that when you shut the VM down, the disk gets deleted. For normal servers, that's terrible. For us, that's great. Right? We wouldn't create destroy. Ephemeral disks are very good, love them, but then, instead of doing that power on, which is one rest call, now you've got that create, which is 3. So bear that in mind if you're changing from a power on to a create destroy with ephemeral disks and that sort of thing. So if you remember that we had that big buffer, so that changes the maths when you're looking at reserved instances to pay-as-you-go, doesn't it? Because now you've got to keep a whole lot of VMs on anyway. Or maybe you want to look back at reserved instances. Because then you don't have to worry about it. You can just keep them up all the time. Nobody cares. You've already paid for it. All of these problems go away. And seeing as you're going to have to keep those VMs on anyway, then taking the reduced pricing for reserved instances may well be good. The crossover point for 1 year is really close. And if you're doing 3 years reserved instances, it's almost, in every situation that I've modeled, 3-year reserved instances is cheaper. Of course, you completely lose the flexibility that you get from pay-as-you-go, but you take your chances. Given that these API limits are per VM, not per session, okay, well, we won't do single session. Well, let's do multi-session, and let's do big VMs, right? Instead of 8 people per VM, let's put 20 people on a VM. And then we can scale out much quicker because our API limit isn't being hit so hard because we've got bigger VMs. All of that's great, apart from at the end of the day. So at the end of the day, right, so this big red square, as everybody can no doubt see, that's a server. The small blue squares, those are users, as is obvious. And the blue squares disappearing are, you guessed it, people logging off. And not only do they do that, they log off in a random order, right? And if you've got one server, this is super simple. People log off and you turn it off. Or what if you've got 512 people? And I've got 16 users per server. And shout this out. Would anybody like to guess, and these are all going to log off randomly, what percentage of people do I have to have logged off before you can turn one server off? 80? Anybody else? Let's do it. So this is obviously a Wednesday afternoon. People have got some work to do. They've decided that, you know, they want to go home, try and beat the traffic, and they're just going to sort of log off randomly from all of your servers that are sitting in the cloud. 25% of users gone. We are nowhere near being able to turn a server off. So let's carry on, and let's let a few more people go home. If you're wondering how I did this, by the way, and how I made it completely random, I wrote these slides in PowerShell. This, in the next 3 slides, is 1,700 separate animations. So we're getting quite far through now, and we still haven't managed to turn a single server. 75% gone. Okay, first one. Whoever guessed 80, they were very good. 78% of people gone before you can turn off a single server. And let's see how many users you have to have logged off before you can turn off half your estate. And I think being able to reduce your spend by 50% is a good number to aim for. So let's wait till a few more people log off and a few more servers get turned off. And we'll see how many people we have left on when we get to half. There we go. Out of 512, we only get to half when there's only 21 users left, or 96% of the population has gone home. We'll let those people go home. So I did it properly random, so maybe that's a fluke. So now it's a Thursday night, they're a bit more anxious to go home, so we'll do it at 2x speed. And we won't do any stopping along the way. And we'll see whether that randomness, how big that variation is, right? And everybody's disappearing very quickly. And we're going to get to the first one just there. And you can see that we're getting a different pattern because it's not the same again, right? It's a whole different randomness to the users. 21 users left again. Exactly the same result. Or maybe that's a fluke. All right, well, we'll do it one last time, but now it's Friday night, and everybody really wants to go to the pub, right? So we'll do this significantly quicker. So now it's 4x speed. You can see why I did this in PowerShell, right? All right, 19 users left, but still 96% of the population. So how many times did I do this? 96% go home. All right, we'll leave that. I did it 100 times. All right, and this is how many users left. So we see that, that initial 21 was fairly near the center. Right? There's not that much variation here. So that does hold true. I also did it with a whole load of different VM sizes. Okay, so along the bottom is number of users per VM. And the curve is the amount of people you have to have leave before you can shut half of your estate down. Now, at 1 user per VM, so single session, 50% go, yeah, 50% turned off. For 2 users per VM, it jumps up to 71%. And for 4 users per VM, nobody does 4, do they? We're already at 84%. It gets bad really quickly. And the difference between 16 to 256 is just minimal. So when you're logging off, I said initially, deployment, big servers, yay. Logging off, big servers, not so much, but at the same time, going from 8 to 16 isn't going to cost you that much more in terms of resource when you're logging off. So you can still do big VMs, right? Because the difference between 8 and 16 is 4%. Who cares? You're going to save a lot more of that on the front end by optimizing for larger VMs. So I was really surprised at this. I thought that having bigger VMs would make much bigger difference on logging off. But it doesn't. Does drain mode help? Not really. You can put servers in drain mode. Doesn't affect the maths. I've forgotten what I was going to say on this slide. This is what jet lag will do to you.
Jury duty?
It wasn't jury duty, no. So hang on, let me see my speaker notes. Come on. I'm glad you put my laptop right over here, because now I can see what I'm doing, right? Yes. Right, you put the hammer down and you make users log off and log back on again, right? So that would work, but everybody hates that. You don't want to be messaging users and forcing them to log off and log back on again to make your log off seem better. Now, moving on to migration and disaster recovery. This is especially important there because if you want to stand up a whole load of VMs quickly in a different environment, even if you regularly use the turn on, turn off, in DR, it's deploy. So it doesn't matter in many ways what control plane you're using, that API limit is still valid. So this was about disaster and recovering, but we just talked about that, and I realize I'm out of time. So is there a solution? Improve provisioning time as much as possible, and be predictive. So there's something called event-based scaling. Now, nobody does this yet, but a number of people are thinking about it. And it means that you can take scaling events from things that are not inside your VDI environment. For instance, when somebody walks through the door and taps their smart card on the entrance, you can take scaling events from that. Now, this starts to become a little bit more interesting. Even more with the predictive stuff, machine learning is really good at short time-based predictions when you've got a lot of training data. We have a lot of training data. And we only need predictions of like 20 minutes before we can start to be very granular in terms of how we create the resource for our users. And we can forget all that buffer stuff and we can forget all the other things. We just let the ML engine do it for us. Right, so that, I hope you found that enlightening. And that is my last slide. So thank you very much, and I hope it was useful.
So, thank you.